we will discuss today, but these are not the final only steps we will do. Each data has its own set of problems. Based on that, we have to do the pre-processing. But some of the common steps that we do, we will discuss today. The first step will be check for duplicate variables or columns. We always check for the duplicate variables and columns because the databases, particularly MNC companies operated from different countries, we will commonly see duplicate variables coming into picture. We have to identify them based on the data description. In database, a description is given for every variable. So you understand the description and then find out whether those variables are duplicate variables, and then we will delete them. We have to delete them, these duplicate variables, or else your model will say duplicate columns found. If you don't delete them, at the model building, it will say duplicate columns found, model cannot be built. Now, how do we identify? If the descriptive statistics are exactly same, if the descriptive statistics of two variables are exactly same, with not even a decimal change, that means they are considered as duplicate columns. When I say descriptive statistics, I'm talking about the min, the max, the mean, the median, first quartile, second quartile, and third quartile. If they are exactly matching for two variables, do we consider them as duplicate variables? Okay. So this is how we identify. So when you look at the describe output, you have to find this. For large scale outputs, we run a for loop, comparing where any two variables have same output or not. You write a loop of the output of the describe function, and then you will try to compare the outputs to see if there are any variables that have common output. We have to delete them. Second, single variable columns. Single value columns, which means all the cells in the column has same value. Zero, zero, zeros. Either it will be a null value column. That means all the cells in the values and all the cells in the column are null. Or sometimes in some databases, the developers will create 111 column to add the sum count. That's the old generation SQL code. To sum up the text variables, you have to create a what you call numerical column corresponding to it. Then you sum total the whole column, you will get the total counts. That's the old days SQL things. Nowadays, you don't need to do it. The SQL query will do it in the backend. Old days, we have to create a parallel column to the text column, add the numbers, then we do the number summation or the number counting we used to do. That will have either if it is one single value, 1111 will be added. If you're counting the total number, it will be 111 and the sum of the ones will be taken as the count. Now you can see this null value column or a single value column will be there. We must delete this. Now, how do you identify? When min is equal to max is equal to mean is equal to quartiles, everything is same. It means it's a single value column. Min is max, everything is same value. It is a single value column. That also you have to identify and delete them. The third and the most important and the most critical task is the missing value treatment. Now, missing value treatment is a very, very complex task. We have to identify missing values variable wise, and if it is a numeric variable, we can do mean or median imputation. If it is non-numeric variable, mode or most frequent imputation. Now, manual imputation does not consider the impact of other variables on the missing values. So both the above methods are manual methods. Both the above methods are manual methods where you will take the column mean, column median, or column mode, and then you will replace it with the missing value. Here, other column imputation, other column impact is not taken into considerations. Then we have algorithm-based missing value imputation. This imputation takes into account the impact of other variables on the missing value and impute accordingly. Yeah. Replacing missing value. Replacing missing value is called imputation. One of the most popular algorithm is MICE. Missing imputation using chained equations. It simultaneously imputes both numeric and non-numeric variables using regression and classification methods. MICE is a very, very popular algorithm. As of now, MICE is in experimental stage in Python. You will get it in R. R MICE is already implemented with various options. As of now, if you want to implement MICE, you have to depend on R. Python iterative imputer is on experimental basis. Next release of sklearn, it will be finalized. Second is KNN based imputation. K nearest neighbors algorithm uses distance calculations to impute missing value. Works well only on numeric data. Third one, probabilistic PCA. Principal component analysis algorithm is used for missing value imputation. As of now, this is not available in Python, but this is available in R and all cloud-based machine learning workbenches, Azure, AWS, and GCP, they are available. Tree-based algorithms. Also are used for missing imputations. Oh, we have, okay. We have not discussed the decisions, okay. Okay. If missing values are less than 10% and there is significant amount of data available, we can delete the rows that has missing values. If you have very few missing values, 1%, 2% missing values are there, and if you have data in lakhs of rows or millions of rows, you can delete those missing values. So first thing, before we go to the imputation methods, you have to identify how much of the percent of the column is missing. If it is in single digits and you have very large data available, you can delete them. If missing values are 70% of, are more than 70% of the column and the variable is deemed to be important, do not impute with mean, median, or mode. Impute with word missing or not available. If a column has more than 70% missing values, that means 85% of the column is missing, we cannot do any imputation. We will use the word missing. We'll replace the missing value with the word missing or not available. But you have to replace the value. If you have missing values, algorithms will not run. If you have missing values, algorithms will not run. So you have to do something. So we will replace it, the missing value, with the word missing or not available. The process of imputation will happen if the missing values are less than 70%. If missing values are less than 70% of the column Then based on data type, mean, median, or mode imputation can be done. So the first thing in missing values you have to check is what is the percentage of missing. That's why you will get to know once you run the missing value function, you will come to know how much percent of the column is missing. If it is in single digits and if the data size is large, we will delete those missing rows. If the missing values are more than 70% of the column, and if you think the variable is very important or significant based on your initial exploratory analysis, we will impute it with the word missing or not available. If it is less than 70%, based on the variable type, if it is numeric or non-numeric, if it is numeric, we'll take mean or median. How will you decide mean or median? Again, based on distortion. I told you, na, mean gets distorted. If mean is distorted, then use median. Now, sometimes the data will have only whole numbers. There also, we should not use mean, we should always use median. If the data is only whole numbers, like 1, 2, 3, without any decimals, there also we have to do median imputation. If you try to do mean imputations, you are inserting decimals into a whole number column. So you have to make the decision. For categorical data, only one, which is mode or most frequent. Sometimes your client will say, I don't want you to do manual imputation. We want to do the algorithm-based imputations. Algorithm-based imputations will take into consideration the impact of other variables on the missing value, and then they do imputations. So they are very powerful. They take time, but they will consider the impact of each variable on the other variables and the missing value, and then they do the imputation. That then considered as robust. Sometimes we experiment. If the data values, if your client says more than 70% missing values, still you do missing, then the safe strategy would be run a mice algorithm and let it do the missing value imputation. The algorithm will use certain formulas and metrics, and then based on it, it will do imputations. So mice, KNN, probabilistic PCA, they are very powerful algorithms, tree-based algorithms like random forest. They are very good at imputing missing values. So they take the impact of other variables. They take the impact of other variables and then impute the missing values. They don't do manual imputations. They are very powerful. The only thing is you need to have time. They take time. Sometimes they may need hours of time to run based on your how much data you have and how much computing power you have. So missing values are the biggest headache in data science. And they are the biggest challenge. If you don't do them properly, you will have a lot of issues. Your models will fail. Your models will have problems in terms of accuracies. So these are the methods which you have in terms of missing value treatment, which is the core of your data science. Real-time data will have missing values. Either due to the hardware infrastructure failure or due to the wrong schemas written in SQLs or because of some human errors in terms of entry of data. So the three broad reasons will be hardware infrastructure problems, like sometimes the sensors might malfunction, or you have written some servers might malfunction and stop collecting the data, or it can be human error where people have written wrong schemas in SQL, or they have entered data wrongly in the database. So all these things will lead to missing value problems. And we have to deal with these missing value problems. And then we have to, once you treat missing values, then only algorithms can be run. If there is one single null cell or a missing value cell in the data, no algorithm will run. All right. Any doubts in missing values? Yeah. We will be using all these methods during the course. We will implement all these methods in both Python and in R. All right, can we move forward? The fourth and the other important task is data transformation. Data transformation or transforming the data structure and type. This is a very, very critical step. Post missing values, data transformation is also very, very important step in data science. Data transformation for dependent variable Y. Dependent variable is the variable which we are predicting. The variable which is being predicted by building the model, we call it as dependent variable, which is denoted by small y or lowercase y. Now, in dependent variable, what do we do typically on dependent variable? If it is numerical and continuous, dependent variable, numerical and continuous. We identify skewness, kurtosis, and outliers. Now, parametric algorithms have fundamentally an assumption that of closeness to normal distribution or bell curve. Parametric algorithms will have a fundamental assumption that the numeric variable must be close to normal distribution or bell curve. Now, how do we find this? Using histogram, box plot, and density curve. The three plots which help us to understand whether the variable is closer to normal distribution or bell curve is the histogram, the box plot, and the density curve. Now, once you plot it, you find it is positive skewness. Positive skewness means what? The peak of the curve is onto the left side. It is onto the left side. Now, if it is positive skewness, we can use logarithmic transformation or square root transformation. That means instead of taking the actual value, we will take log of the values. We will calculate for each of the value, logarithmic value, and we will take those logarithmic values as our dependent variable values. If there is a positive skewness in your dependent variable, the primary method is logarithmic transformation. If at all logarithmic transformation does not work, we go to square root transformation. Now, based on my experience, if logarithmic transform does not bring the data closer to normal distribution, we have to go to non-parametric algorithms. No point in trying any other method. Non-parametric algorithms does not have the assumption of normal distribution. They will work with any type of data. So only the basic algorithms like multiple linear regressions, they have the strict regulation of normal distribution. If it is negative skewness, the opposite of logarithm is exponential. Exponential transformation or power transformation. So you need to apply transformation and see if there is. And one other thing you always remember, you cannot eliminate skewness, you cannot eliminate outliers, you cannot eliminate kurtosis. You can only minimize them. You can only reduce them, but you cannot eliminate them. You can only minimize them to an acceptable level. You cannot eliminate skewness, you cannot eliminate kurtosis, you cannot eliminate outliers. You can only reduce them or minimize them to a lower level. That too might work, might not work. If it doesn't work, we will go to the advanced algorithms, which are the non-parametric algorithms, neural networks. There are some very advanced algorithms that work on any type of data. All right. Any doubts? If the dependent variable y is non-numerical, then we have some problem called imbalance data problem. Imbalanced data. Imbalanced data is another problem when your data is non-numerical. Yes or no? Let us say imbalanced data will be like this. Yes is 4,500 and no is 55,500. See, so much of difference between yes and no. If you want a balanced data, balanced data would be yes 24,000 and no 26,000. Or let us say it can be 2040 also. 20,000 yes. Or let's say 25,000 yes. 35,000 no. This is a balanced data. 60-40, preferably 50-50. But 50-50 is again a problematic scenario. 60-40, 75-25, okay. But 80-20 is not okay. 90-10 is not okay. 95-5% is not okay. So we have to balance the data. When you have imbalanced data, that means too much of one category and very few of other category. We refer to as majority class and minority class. We refer to it as majority class or minority class. Majority means very large, minority means very, very small. Now we have balance methods, both oversampling and undersampling. Oversampling means increasing the minority class. Oversampling means increasing minority class, and undersampling means decreasing the majority class. We will study these sample methods in detail. Undersampling methods and oversampling methods has to be applied on classification data. Now, this is one of the most common problem in real-time data science. Take, for example, credit card frauds. Do all customers do fraud? Hardly 3 or 4% customers will do fraud. 95-97% will pay them on time. Worst case scenario, 10% might commit fraud. If 10% of your credit card holders are committing fraud, RBI will stop your credit card business. No credit card issued, you work on your frauds. So when you look at fraud scenarios, fraud will always be a minority class. Very few, 5%, 6%. 94% will pay it on time. Same for loan default. Same for what you call violations, or same for something which is not acceptable will come only minimum times. There we have to balance the data. Otherwise, your algorithms will predict the majority class correctly, but they will predict the minority class wrongly. They will predict the majority class correctly, but they will predict the minority class wrongly. Even in promotions in a company, 10% of the employees are only promoted, 90% are not promoted. They will get hikes or other things and all. The promotions in any company is only 10% or less than 10%. So you have to look at that data also, HR data. We have to balance it and then we have to do it. Do all the employees leave? No. 10-12% leave the company every quarter. 88% will stay with the company. There also we have a attrition rate 5%, 6%, 10%. Nowadays it is around 12 to 14%, but typically attrition rates will be 8% or less than 10%. There also we have to balance the data. Now there are algorithms also. One of the popular algorithm is SMOT algorithm, is used for balancing, and it is a oversampling technique. Very popular algorithm is SMOT, synthetic minority oversampling technique. It creates synthetic data or artificial data. I will explain you the calculation, how does it do it when we discuss the imbalanced data methods. That's a separate session we have on balancing the data after we deal with all the classification algorithms. Any doubts? Okay, now let us get to independent variables. Independent variables commonly denoted with capital X. Again, if it is numeric and continuous variable, and they are in different mathematical units like tens, thousands, lakhs, or discrete values. Sometimes in your data, you have numerical data in different mathematical units. Take, for example, house data. The price of a house will be like what? How will you quote the price of a house? Lakhs, 85 lakhs, 90 lakhs, 60 lakhs. How will you quote the price, size of the house? 1,000 square feet, 1,200 square feet, 1,500 square feet, 1,000, 1,200 square feet, and 1,500 square feet. How will you quote number of bathrooms in a house? Two bathrooms, three bathrooms, or one bathroom, like that you will quote. How will you quote the balcony size? 10 by 10 feet or 10 feet, some 6 feet, like that you will quote. So in a house data, you have lakhs, you have thousands, you have hundreds. Hundreds might be parking lot size. What is your parking lot size? Or what is the share of the whole property, you know? The 100 square yards is the whole share community. The apartment have the property shares, right? That, and then you have the tens, like that you have different mathematical units. We need to apply scaling. Scaling must be done. You have to do scaling of that data to bring the data to a parity. Parity means to a same levels. The first and foremost is standard scalar, also called as standardization or Z-score. Z-score, the formula is X minus mean divided by standard deviation. For every observation, you will calculate Z-score. For every value, you will calculate Z-score. You will calculate the column mean, you will calculate the column standard deviation, and then using those two, for every value in that column, you will calculate Z-score using the formula X minus mean divided by standard deviation. Standard scalar gives both positive and negative values. Standard scalar will definitely give you both positive and negative values, because some observations will be greater than mean, some observations will be less than. So you will get both positive values and negative values. It will scale within a range. Scale all values in a particular range. Based on your data, it can be -3 to +3, -5 to +5. It will scale the data to that range. But standard scalar will give you both positive as well as negative values, because some observations will be above mean, some observations will be below mean. The second type of scalar, we call it as min-max scalar, or also called as normalization or min-max. The formula is x minus x min divided by x max minus x min. Min-max scalar or normalization or min-max, the formula is x minus x min divided by x max minus x min. Normalization scales all the values in the range of 0 to 1 and no negative values. The min-max scalars, whatever may be the range of values, it will scale it to the range of 0 to 1. And there will be no negative values. When you don't want negative values in your scaled data, you have to use normalization, particularly image processing. Image processing, the pixel data must be positive. It cannot be negative. There you have to use min-max scalar only. You can't use standard scalar in image processing because it will create negative pixel values. You cannot have negative pixel values, it will problem. Pixel values are 0 to 255 and they are only positive. So wherever, whichever situation you don't want negative values, it has to be min-max scalar has to be used. The third type of scalar is robust scalar. The formula is x minus x minus median, x minus q2 divided by q3 minus q1. Why it says q1? It is q3 median, right? No. I think we'll go with the x minus median. X minus median is what? Q2. Q2 or median divided by Q3, third quartile minus first quartile. Third quartile minus first quartile, also called as interquartile range. Interquartile range is also called as Q3 minus Q1. Used when there are large amount of outliers in your data. If the independent variables have huge amount of outliers or large scale outliers are present in your data, you have to use robust scalar. Robust scalar uses quartiles. To scale the data. There are many other scalars, but these are the most important scalars in our machine learning. We have Box-Cox transformation. When you do time series data, I will talk about Box-Cox transformations. And then we have other scalars also. But the three important scalars which you understand in machine learning and data science is the standard scalar, the min-max scalar, and the robust scalar. In interviews, they will definitely ask you questions on these scalars. when to use what scalars is one of the common interview questions we see in data science. So data transformation on dependent variable is different. Data transformation on independent variables is different. The strategies are different. On dependent variable, different strategy. On independent variables, different strategy. All right, can we move forward? The fifth one, and the most important, without which you cannot run algorithm, is dummy variable encoding or label encoding of categorical text data. Whatever text data or character data or object data in your that is there has to be converted to numbers. Assigning numerical identifiers to categorical text data. That we call it as dummy variable encoding or label encoding. Before we do the algorithm building, we have to do this step compulsorily. There should not be a single alphabet or letter in your data when you send the data to model building. If there is a single alphabet or a letter, the algorithm will simply say string data found. An error will come saying string data found. That means there is text data in your data which no algorithm will run. So before we send the data to algorithm, all the categorical text variables must be dummy encoded. Dummy encoding is process of assigning numerical identifiers to each level of the data. There are two methods. The first one is label encoder. Assigns numeric values from 0 to n levels to categories based on alphabetical order. Based on alphabetical order, it assigns numeric values from 0 to n levels. Whatever is the level, it will assign that in alphabetical order. It will override the existing column unless specified to create a new column. It will override the existing column with the numbers. Take, for example, we have a variable called gender. M, F, M, M, F, F, M. Now, what label encoder will do? It will override the column as 1, 0. Because F comes before M. Alphabetically, F comes before M. 1, 1, 0, 0, and 1. This process we call it as label encoding. Assigning numerical identifiers to text data in alphabetical order starting from 0. starting from 0. 0 to as many levels, as that many numbers will be assigned. The second method is, let's say this is your first method. PD dot get underscore dummies. PD dot get underscore dummies creates new columns equivalent to as many levels in categorical variable and uses binary encoding of yes, 1 and no, 0 PD dot get underscore dummies is a function in pandas that creates new columns. In label and column, new columns are not created. Simply it overrides the existing column. In a single column, it will give you the numbers. But in get dummies, it will create as many columns equivalent to the number of levels in your data in that particular categorical variable and uses binary encoding. Binary encoding means yes is equal to 1, no is equal to 0. Now, if I take the same gender example in the top, if you take the same gender example in the top, it will create two variables, gender underscore M. It will create a new column called gender underscore M and uses binary encoding 1, 0, 1, 0, 1. Oh, sorry. M na 1, 0, 0, 1. It will also create another column, gender underscore F. Variable name followed by the category name. Variable name underscore category name. 0, 1, 0, 0, 1, 1, and 0. So here it creates two columns. Whereas in label encoding, the same column it will overwrite and does it. But in get dummies, new columns will be created. Your data shape will increase. Number of columns will definitely increase if you use get dummies. But PD get dummies is preferred in regression problems. PD underscore dummies is preferred method for regression models. For regression models, PD get dummies preferred. Or you can use label encoding in classification models. Or if you do not have enough data, if there is not enough data in terms of rows or observations, label encoder must be used. If you don't have enough number of rows or observations, then use label encoder. If you have enough number of rows or observations, you can go with get dummies.
Any model, like regression or
last.
This for any model, like regression or classification.
Which one?
If there is no enough data in terms of rows.
You have to use any, what can be classification, it can be regression, it can be clustering. It has to be label encoded only. If there is not enough data.
Why it is preferred?
So what happens is when we study regression, I'll explain to you. In regression, the levels also are treated, have interaction with one another. Gender as a whole will have an impact. Within gender, male and female also has impact. See, in regression, what happens is Gender, whether it is male or female, will affect the dependent variable. Gender, whether it is male or female, will affect the dependent variable. Sometimes gender only male affects the dependent variable. Then how will you know? You have to separate them into two different columns, gender M and gender F, and then pass them separately. If you pass the variable as gender 1 and then it has M and F, it will not be able to understand the interaction. But if you split the column into gender N and gender F, pass them to the algorithm separately, then it has the potential to identify whether gender M is significant or gender F is significant. If you want to study like that, which type of gender as a whole also will have an effect, that also you can study, or you can see which particular gender has a particular effect. There, get dummies is a very important. Education. There will be at least 10 levels of education, right? Right from high school to graduate, doctorate, professional, different education levels are there. Education as a single variable will also have an effect, which within education, which have more effect. That also can be studied, but if you have to split them into separate variables, that is what you have to do. Sometimes you have to understand the interaction of variables also. There you have to do get dummies. Then your output will give which level or which subcategory in that particular level has an what effect. Then you can target and focus on the particular categories and levels. Any doubts? Correction of duplicate levels in categorical data. This is also one of the common thing we will find. Take, for example, gender. You have male, you have small m, you have capital M, and then you have all caps. What does all this mean? It means only one single category called male. Because of data input error, you will get duplicate levels. The software will treat them as different levels. In R and Python, they will be treated as different levels. Capital M male, all male, small m, capital M, then all caps male. But what is it all? It is one single category called male. Duplicate levels need to be corrected. Otherwise, it will distort your model. Dates. This is also very, very important. Dates, if they are in default format, like YYY hyphen MMDD will be read as dates most of the times. Or else it will be read as string or object data. Most of the times, if your date is in the format of YYY hyphen or slash MM hyphen or slash DD, Python or will automatically detect it as date. If at all it is in another format, it will be read as object or string column. We must convert date into date time format using, now we have a new function pd.to_date time. Earlier we used to do different functions are there based on time zones, all those things are there. Now it is a single function pd dot to underscore datetime will convert the dates to datetime variable type. You have to convert dates to date time format. In Python, it is date time ns. Nanoseconds. Seconds, microseconds, and nanoseconds. Maximum is nanoseconds. Yeah.
So in whichever format the date is, we use the standard format.
You have the standard format is why it has to be converted into standard format. The date time function will read the date automatically, or you have to specify the existing format. Based on the existing format, the date time function will convert into the default format.
In the columns, we have two formats like integers.
So if you have different formats, we have to bring all the formats to one, or we have to, that's a very complex process. So what we have to do is, if we have different formats, we will split the column based on delimiter. Whether the hyphen or slash or whatever is there, we split the data into new columns, then format them, then we again merge them into one single column. It's a very complex process. So what generally we suggest people to do is try to work with dates in Excel if possible. If you don't have any option, you have to use pandas. If you have to use Python or R only, in R we have a library called lubridate. Now lubridate is very advanced. It will take any type of date in the same column. If there are multiple types, lubridate will automatically read multiple types and will convert it. Automation is there in R, but not in Python. In Python, we have to split them based on the delimiters into different columns, then correct the dates in different columns, then we have to merge them back into one single column. So all slash dates in one column, all hyphen dates in one column, rest of the cells will be taken as null. All the alphabetical dates in one column, then you convert them using the datetime functions, then you merge them all into one single column. Three-step process you have to do based on the delimiter, hyphen or slash or alphabet, three-letter alphabet, full name, whatever it is you can do. Whereas in case of R, the lubridate library, which is exclusively date library, will automatically read all the date formats and it automatically converts them into one. R has an advantage in dates compared to Python. But Python also, the same lubridate is being developed for Python. Maybe in the next version it will come. Extracting information from dates. Like weekday, month, quarter, year, is month start, is month end, etc. So based on the date, once you format the date, we can extract weekday, whether it is Monday, Tuesday, Wednesday, or what day it is. We can extract month, what month it is. We can extract the quarter number. We can extract the year. If you have mapped the seasons, time zone is mapped, we can also extract the season. You can extract season also. And if you have mapped the list of holidays, you can also identify whether it is a holiday or not. But they are not automatic, you have to map them to the existing data, and then we have to write a loop where the holiday list will be compared with the dates, and then the specific dates will be identified as holidays, and then we can use them for identifying whether it is holiday or not. But all this thing can be done only after converting it into date format. Only after converting the variable to a date format, you can do step 8. Otherwise, you cannot do step 8. Very simple. dt dot weekday. It will extract the weekday for you. Date dot dt dot weekday. Date dot dt dot month. Date dot dt dot quarter. DT means date time. Date time is a library. It is part of NumPy itself. Pandas. Pandas date time library. Now it is integrated into Pandas. It is referred to as DT. variable name dot dt dot weekday. It will give you the week number. In 52 weeks in a year, what is the week number? First week, 14th week, 38th week, like that week number also you can generate. So all these things can be done from dates. Creating new variables from existing variables. You create new variable from existing variables by combining or by subtracting or addition or multiplication of two or more variables. Creating new variables from existing variables. It can also be ratios based on division. Extracting information from alphanumeric codes. Sometimes you'll see alphanumeric codes, alphabets and numbers. Their alphabets might represent some information. So you have to extract those specific alphabets or specific values. So alphanumeric codes might contain some information that we have to extract. Concatenation of variable columns or rows is also important. Concatenations, side by side pasting, different to merge or join. Concatenation will do if you are concatenating columns, first set of columns, second set of columns. If you are concatenating rows, first set of rows on below, second set of rows. So concatenations are widely used in data preprocessing. Joins and merges are also used at the beginning level of data, but during the pre-processing stage, concatenations are widely used. So within concatenations, axis is equal to 0 refers to rows. Across Python, axis is equal to 1 refers to columns. Across Python, not only in concatenations, in any other function, if you see axis is equal to rows refers to axis is equal to 0 refers to rows, axis is equal to 1 refers to columns. Merge and all use conditions, right? In merge and joins, you have inner join, left join, right join, you have cross join, self joins, different types are there. But in concatenation, simple pasting, side by side pasting, that's all. There is no other arguments here, only side by side pasting. Whatever you give first, it will paste those first, next to it, it will paste the second. If you say paste rows, it will do that. Whereas in join and merge, you have other arguments to be given, whether it should be left join, right join, or inner join, or is it a self join or a cross join? Without that arguments, it can't work. Whereas in concatenation, it's simple pasting side by side. Converting numeric variable to categorical variable, typically high, medium, low. Sometimes you need to convert numeric variable to categorical variable for extracting information. Okay. So these are the broad pre-processing steps which we do. One last thing is there, aggregation of data. Aggregation of data based on ID or unique values group by customer IDs. A customer might have done multiple transactions, right? We have to combine all of the customer transactions into one under one customer ID, and then we sum the total value. And we count the number of transactions. That also we have to do aggregation of the data based on ID or unique values. That's a common process we have to do. These are the common things which we do in data pre-processing. But each data has its own challenges. Not that sometimes you have to do a lot of other things also. Subsampling, that means if it is a very large data, you have to randomly subsample to 5 lakh. Suppose client gave you 30 lakh rows. You can't build a model on 30 lakh rows on your CPU. So you have to subsample. You have to randomly sample it to 5 lakh rows, or you have to randomly sample it to 10 lakh rows, 30% of the data. You take client permission and subsample it. There are libraries available for random sampling. Then you start working on with that particular data. We always, preferably for building models and testing and all, we always look for not more than 10 lakh rows. Not more than 10 lakh rows is what we generally look at. If it is more than 10 lakh rows, it creates problem because 10 lakh rows is the limit in Excel. That is why we go with 10 lakh rows. Otherwise, there is no such reason because in Excel you have maximum 10 lakh 45, right? In a sheet, you have only 10 lakh 45. So preferably we want the data to be in a table format in a CSV or Excel. We generally go with that type of notations. So this is what one data, see, this is a real-time data of casino related data. It has 4 lakh rows. And you can see there are missing values. You can see, right, empty cells. Zones, there are empty cells in zones, categorical data. We have empty cells in game devices, serial number. You might have empty values in categories. See, lot of missing values, -1. See, you have single values also coming into picture. -1s, 1s. So these are all problems you need not applicables. See? No, it's a unique, it is distorted value. No? It's text and a number value. How can you have both? It has to be single data type. It cannot be multi-data type. Now, what this -1 means, we have to see why this -1 came into picture. And you can see here, there are completely null cells. This is what happens with real-time data. People, I think PJ 17 students, they are working with this, they're really struggling. The client See how much of work it has to be done. They're still working on pre-processing only. Last 10, 15 days, they're working on this data. Till now, the data is not clean. Still, a lot of issues are cropping up. They are struggling. They are having problems in finding the what you call cleaning up the data itself is not done. Forget model building. And every time they do, some new problem is coming. Yeah, it's a binning only, high, medium, low. You can call it as binning also because you have a frequency, na? Sorry, you have a category, class interval. Greater than 30 high, less than 20 to 30 medium, less than 20 low. So it can be called as binning also. But binning is again where you can convert numeric also into numeric data. Binning is used in exploratory data analysis. Binning is widely used in EDA, not in pre-processing. So one type of exploratory data analysis is binning. Like how many customers are doing 0 to 1 transactions, how many customers are doing 2 to 4 transactions, customers doing 5 to 6 transactions. Like that, you can create bins of a numerical data, and then you can do the frequency count of that particular bin. Yeah. Label and code. You have to label and code.
What is the use of creating new variables?
If existing variable is not giving any information, any value addition to the model, you have to create new variables by combining or addition, subtraction. So you have to constantly create new variables if your existing variables are not giving you proper value addition to the model.
We will be using that dummy. If we have more than 10 levels.
Yes, it will create 10, 20, 30 levels also it will do it. That's what I told you, data size is important in GetMS. Or else you have to reduce the minority levels to miscellaneous or others. Miscellaneous or others have to be created before doing the GetMS. One-hot encoding is similar to GetMS only. 0, 0 and 1, 0. I don't want to get too confused. Once we do that, then only understand. One-hot encoding is similar to the GetDummies only. But it will not create new columns. It will do it in a single column. Zeros and ones only. Encoders will talk when we are implementing them because if you understand GetDummies and label encoder, then it is easy to understand the one-hot encoder and all. Otherwise, you'll get confused. I told you, regression models GetDummies. For regression models, as long as you have data, use GetDummies. For classification, anything will work. It is depend on the number of rows you have. Because for regression, minimum 20 observations per variable. For classification, minimum 50 observations per variable. That is the rule. Minimum 20 observations per variable for regression, minimum 50 for classification per variable. You have to reduce the variables. You have to reduce the variables either by manual selection or you have to decompose using principal component analysis or dimensional reduction techniques. And if you have extremely small data, you can't do anything. All right. So all of you downloaded that Big Mart data. Import the data. So train file is the file which you will be using for building the model. It has the complete data, including the dependent variable. Test file will not have the dependent variable. It must be predicted using the train model, and the sample submission, you will copy the predictions and upload it to the competition site. In the existing data, you can see here, train data has 12 variables, test data has only 11. The one variable which is not there is the dependent variable. And that dependent variable needs to be predicted. How do we predict? We have to first build a model on train data, and using that model, you will predict on test data. Then you'll get the predicted values. Once the predicted values are got, we paste them into sample submission and we upload it into the competition site. So, all of you have imported the data. Figma train.info. So what do you observe from the info output? There are missing values. Yes. Item weight has missing values. Outlet size has missing values. Item weight is a numeric data. Outlet size is an object data or character data. Figma test.info. So what do you observe here? Same variables have missing values in both train and test. For data pre-processing, train data and test data must be concatenated. Whatever pre-processing done on train, same must be done on test data. Hence, concatenation must be done. The first step in data pre-processing is we need to combine the data into one. Train and test data must be combined into one data frame, because the pre-processing which you are doing on train data, same pre-processing must be done on test data also. To avoid duplications, to avoid mistakes, it's better to combine them into one data frame and do the process only once. Do the process only once. Thereby, you will eliminate mistakes and you will eliminate unnecessary issues. Now, but for concatenations, the number of variables and the sequence of variables must be same. For concatenation of two data frames, the number of variables must be same and the sequence of the variables must also be same. If there is a mismatch in variable names or sequencing, you cannot concatenate. So in our case, both the data frames variable sequencing are same. You can check if they are exactly same. But the only problem is train data has one additional column. Train data has one additional column. Now you have two options. You can remove the train data, the dependent variable from train and then concatenate both the data frames. Or you can temporarily add the dependent variable to the test data and fill it up with a single value like test or some value. And then later you can split the data frames based on that condition and then we can delete the dependent variable from test data. So generally we follow this, because what is the problem here is Python starts with 0 and outer value will be ignored when you're subsetting the data. So that is where we make mistakes. Sometimes when we count and separate the data, we make mistakes. But if you use a condition like equal to test, not equal to test, that problem will not happen. So what I will do here is I will temporarily add dependent variable to the test data and fill it column with the word test. Fill the value in that column. The column should have value, right? That value will be test. TEST, a single value will be done. So that in the last, I can split the data frame. Equal to test is all test data. Not equal to test is all train data. A conditional statement can be written and I can split it. No ambiguity, no errors will come up. Now, let us create the dependent variable in test data. Big mark test square bracket, make sure the name exactly matches. So what I'll go is, I'll go to the train data variable names, copy it, Control C, single or double quotes, place the thing is equal to test. So I am adding a new column called item outlet sales to test data at the end. By default, new column will be added at the end. And the name of the column is item outlet sales. Exactly same name what is there in the train data set. And I am filling the whole column with a value called test. With a call test. Now the number of columns in both train and test data will be same. And the variable sequencing will also be same. Now we will combine both train and test for pre-processing. Combine df is equal to pd.concat, open bracket, square bracket, big mark train, comma, big mark test, come out of the square bracket, axis is equal to 0. Axis is equal to 0 refers to row-wise concatenation. Axis is equal to 0 refers to row-wise concatenation. That means first it will paste all the rows of train data. Below it, it will paste all the rows of test data. Now you can see the shape. Combine df dot shape. 14,204 observations of 12 variables. Now we have combined both the data frames into one single data frame for pre-processing.
Why we use row-wise?
Because the rows we have to now first paste all the train rows, and we are doing row. We are combining two data frames row-wise. You can't put them column-wise, right? Same variable names. Duplications will happen. Duplicate columns will create.
So if you have the same variables in both the sets, but then jumbled.
You have to bring them to the same sequence. Otherwise, you can't concatenate.
So what if we have like more than like find the variable missing from the data, so we can include like more than 4 5.
No.
Like suppose the train data has like 15 columns and let's say that we have 11.
So we have to look at those 4 columns. Why they are missing, you have to find out first. If they are missing by error, you have to get the data for 4 columns, or else you have to remove them from the train data itself.
If only one is there, then
Because you can't use them. If the same variables must be there in train and test. If train has it, test does not have it, you have to delete from train. Otherwise, your model building is wrong. Okay. Now, find missing values. Combine df dot is null dot sum dot sort underscore values ascending is equal to false. Otherwise, it will give you ascending is equal to true, smallest to largest. We want largest to smallest. We want the maximum missing values on top and no missing values in the bottom. Observe the output. You will understand why we are giving that arguments. Yeah, we have combined both the data frames into one called combined DF. It will be by default coming as object data type. It will come as object data type. You will come to know only when you do variable description, data description. It becomes object data. Yes. That is a different pre-processing you have to do before missing value treatment. Total number of missing values in the column. How will you know? You want individual missing values or you want total number of missing values in that particular column? It will for is null is a function to identify missing values. Then sum will total the number. Is null is a function to identify whether the cell has a value or not. Whatever is not happening, it will total them. Sum will total it. Then you are using the sort to do the descending order sort.
Can you use count?
Count cannot be used. Count is different, sum is different. What is shape output? Dot shape. What is the output of dot shape? Dot shape is number of rows and number of columns. Shape 0 means number of rows. Shape 1 means number of columns. You have to divide it by number of rows, right? That's why shape square bracket 0. Accessing. You remember the indexing accessing. Square bracket is subsetting, slicing. Shape 0 means number of rows. Shape 1 means number of columns. The output of shape gives you number of rows, comma, number of columns. So 4,000 rows have missing values divided by 14,204 rows. 28.27 percentage. All right. So less than 70% missing values. So we can do imputation based on the variable type. Combine df dot outlet size dot value underscore counts drop na is equal to false. So in outlet size, there are 3 categories: high, medium, and small. And missing values 4016. There are 3 categories in outlet size: high, medium, and small, and missing values of 4016. Now, what should we do? So what should we do? If we replace it with the word medium, the medium category becomes 8,000. That means it becomes a larger category, which will create a distortion in your data. If you add them to small category, again, it becomes 8,000. You are creating distortion in data. If you add it to high category, it will become 5,000 things. That is again distortion of data. When you cannot add it to the existing variables, with existing categories, keep it as missing or not available. The safe strategy is always to keep it as missing or not available. So we will, since there are many NAs and cannot be replaced with existing categories, huh? Drop NA means don't drop NA. Drop NA means what? Give me all other values other than NA. We don't want it to happen. Drop NA is equal to false means give us NAs also. That is a sub argument. Drop NA true means it will not give you the missing values. By default is drop NA true. You don't know how many missing values are there. You will know how many missing values are there.
Any value we need to add to the medium, right? So
If you add it to medium, then it will become larger category. That is wrong, right?
if it's like small, too like small.
Then we can add it. If it is a smaller value, then no problem. Based on the frequencies. Fill NA is a function that fills the missing values with the word we specified or the value which you specified.
We can add it to kind of like it will be of something that will be maybe somewhere with you.
How can you have high number of stores? Your whole see, high sales stores will be very high number for that business. Then how can it be? Typically in retail, high sales stores will be always minimum, right? In typical common sense knowledge, will all stores have high sales? Very few will have high sales, right? Typically, where will you have high sales? When the store has larger population and it is there, you have high sales. High value products are sold, you will have high sales. Other places you will have low sales. So you cannot give it to high. High is a very dangerous scenario. That means you are saying the business has only high value stores. No, it's impossible. You have to use logical thinking here. For any business, high values will always be less than 20%. That is the industry level data. Any business, not more than 20% will be high value, high level sales. Even if you look at marketing sales professionals, will all of them have high sales targets? Only few of them will have, right? So I will now go to the top and run the missing value command. Now all the missing values are gone. Zero missing values. Combine df dot item weight dot describe. So what should we do here? Item weight. What is the mean? What is the median? Yeah. 12.60. Second quartile is median, 50%. Mean is 12.79. Median is 12.60. Both are closer to one another. You can use any of them. There is no distortion. There is no distortion. So we can do combine df dot item weight is equal to combine df dot item weight dot fill na combine df dot item weight dot mean. Mean imputation. Now I'll run the previous command again. Now you can see 14,204. Is numeric na? A numeric data hai. How will you use bond? This is numeric data, right? Weight is what? Numeric. When there is a huge difference between mean and median. Two times when you will use. In this case, suppose mean was 12.79. If median was 8.40 or 8 something, then we have to use median only. Second thing, if the data is single value, that means the whole numbers, no decimals. Mean will be always decimal, right? Mean will always be decimal. There you can't use decimal, so you have to use median. Median will always be whole number, 95% of the times. Very rarely we see decimals in median. That if the data itself is in decimal. But in this case, if median was 8, then we could have gone with median because mean is distorted. Right. We will go through. We have not checked the thing, whether the distortion, how will you check? Based on the outliers. You have to do a box plot of weight. Do a box plot of item weight. Now I think it will get a good plot, but prior you should have done it. Now if you do a box plot of item weight, see, no outliers. Okay. Because there is not much of a change. Huh? What happened? Item weight dot plot kind is equal to box. What is equal to false? So this is very stable data, right? No outliers. Mean and median were very closer to one another. Okay. Now we'll go variable by variable. Combine DF dot columns. The first variable is dot item identifier dot head. Mhm. Again, your data was distorted. You might have run with wrong spelling or something. Mistake. There was no data. It was null. That's why you're not getting the data. So you have to do the combine again, correct the statements and rerun all the statements again. So you did that again. You have corrected yourself. Whenever you correct any function, you have to go back and run all the previous statements. Otherwise, you will not get the data. Null means you have corrected it, but you have to run from the point at which you combine the data. Run compare one step, then you get the data back. Re-import the data, first correct the mistake. And then go back to the point where you have created the data. Run from there again, all the cells. First correct the mistake, Then go back to the point where you have created that particular data. Ah. So what you have to do is you have to go to the original. First, you correct the item outlet sales name. It was the name mistake. You have to correct the name. Then go and re-import the data again and then combine the data again. Previous data point where there was a change in the data from that point you have to run. But before that, you have to correct the mistake. Now, if you look at the identifiers, it's alphanumeric. Like I told you in retail, alphanumeric means product codes will be there. So if you look at the first two letters, it might represent a code, item code or a product code. So we will extract it. We will extract item underscore code. We will create a new column, item code from identifier. And then we will drop the identifier column. Combine dir, square bracket, single quote, item underscore code is equal to combine dir dot item identifier dot apply lambda x colon x square 0 colon 2. So we are splitting the data. Lambda is an iterator like for loop. Lambda is an iterator like for loop. So for every cell, it will get the first two alphabets. And a new column we are creating, item code dot value counts. So we have three categories in our data: food, non-consumables, and drinks. So lambda is a anonymous iterator. Iterator without name. Anonymous means name. Because in iterators, we always have a name. For X in list of columns, colon, and then you write, right? So if you want to use iterator without any name, the keyword is lambda. And then X colon X0 colon 2. That means you are asking it to split the first two letters of the cell. Since there are multiple cells, 14,204 cells, we need an iterator. It has to go through all the 14,204 cells, right? So lambda will run through all the cells one by one and extract it and save it into a new column called item code. We have 14,204 cells, right? All the cells must be applied to the same function, X colon X0 colon 2, 0 and 1. That means 0 colon 2 means what? First two letters, 0 and 1 alphabets. So it has to be run on all cell one by one. The lambda will do it one by one and it separates the data into a new column, item code. 0 colon 2 means what? 0 and 1. Outer is ignored. Square bracket is what? Selection of the subsetting or selection, slicing. So each identifier will be sliced for the first two letters, 0 and 1. We have identifiers as alphanumeric, right? So first cell, these two letters will be sliced. Second iteration, this will be sliced. Third iteration, this will be sliced. So it will do 14,204 iterations. Slice the first two letters and then save them into a new column called item code. First, it will execute the slicing operation. put it into an array, and that array will be converted into a column automatically.
But it is, we have to take only first two alphabets or
See, depends. You want to try 3 letters, you can try.
why it is like,
Huh?
why it is like,
Because the categorization is the FD is food. In the problem statement in retail, they given FD represents food, NC represents non-consumables, and DR represents drinks. This is the categorization given by the company itself. Food items, non-consumables means soap, toothpaste, brush, detergent, like that. Drinks means soft drinks, beverages, any drink. They are given the categorization of the first 2 letters. Because the third letter is again changing, right? Third letter is changing. Common is first 2 letters. So sometimes you have to print 100 crores and then you have to see whether it is first 2 letters or 3 letters. Head of 100 or tail of 100, and you have to check it. Here from 6 only I can see the third alphabet is changing. So I will go with 2 alphabets. You need to have knowledge. That's what subject knowledge is required here. This is retail data related to superstores. You need to understand the sector and then you have to do it. In the Capgemini statement, the problem, the team doesn't know anything about casino. They never went in their life to casino. They don't understand what is casino data, but they have to work upon it. So they called me, sir, what is this casino data? We got to know what to do, where to do. We tried to see some videos. It's all gambling and all. So I have to explain. Because I visited a lot of casinos and all. I know the business and I have told them this is the business, the slots, what it means, what is roulette, what is blackjack, what is different games, what card games, wheel games, slot machines, all those things will be there. Without that knowledge, you can't clean the data. And they don't know anything because they never went into that scenario. So they were completely unaware. So ask them, look at the videos in YouTube of casinos. You have a lot of videos. They'll explain what is a table game, what is a wheel game, what is a slot machine, what is a, what you call blackjack, what is poker, all those things, it will be there. So they watch the YouTube videos. They understood what is casino, what is its business and all. They have studied the articles. Then now they can work on data. Without this knowledge, how will they work? First bet, second bet, then what is the different types of bettings that happen. So they have to do it. I told them, you tell the client you need 5 days time to understand the business of casino. 5 days you take them, see the videos, read articles, understand. Then only you can do it. Otherwise, you will not understand the terminologies, you will not understand it. And if you say, I don't know, your boss will say you can leave. It's as simple as that. They have to work. Their job is to learn and work. They can't say, I don't know. You have to understand. So how will you understand? Use the internet, YouTube videos are there. And read the videos, read the articles, understand the business models. How do they make money? What is the importance of which variable? 5 days I told them, you tell the client and read. Every day read the business models, articles. A lot of information is available on internet. How do they make money? So all those things you need to understand. What is odds? What is spread? What is first bet, second bet? How the settlement is done? Cash outs, cash ins, all these things you need to understand. Otherwise, how will you work on the data? The data is all those things. So you need to understand. Then only you can work. Now they have some idea of understanding casino. I told them, if possible, travel to Goa, visit a casino, and then you have to do it. Otherwise, nothing. You have to spend your own money. It's as like that. I tell you what, you have to go to field. FMCG business, 3 months back, same thing happened. FMCG forecasting. I told him, go to a supermarket or kirana, study the products. FMCG data, talk to them. Forecasting of biscuits. So you have to understand what biscuits are there, what type of biscuits are there, what is the difference between a cookie and a biscuit, what is biscuits, low level, low cost biscuits, medium cost, high end biscuits, cookies, muffins. Then you have potato biscuits now, the latest version. So you have to understand them, otherwise you can't work. It is impossible to work on data without knowing the fundamentals of that particular data. So I told them, you have to visit. If you are still in doubt, go see the thing in yourself, look at it, and then come back, and then you will have an idea. Because I'm sure you guys will also not have any understanding of this data. Because the variable names are completely different, and understanding that without understanding what they will do. Huh? They will give description. What will you understand from description? They will simply say playtime in seconds. What is the playtime in seconds? It differs from game to game. See, number of seconds a player played. In description, what is given? Number of times, number of seconds for each play. That is the description they have given. Then play minus, wait time seconds. How much time he has taken to make a decision to bet or not to bet. Now, these guys don't know what is this. We will not bet, right? Once the other plays, you have 30 seconds or 20 seconds or 10 seconds to have a time to either take the card or throw the card or whatever it is. That decision time. Cash in amount. Cash out amount. Cash in means you are withdrawing money from the casino. Cash in means you're paying the money. Cash out means you're taking out the money. Jackpot amount. Jackpots are lucky draws. See, Theo amount. Theo amount is like bonus. Game manufacturer code. Game manufacturer long description. Game style, video slot, reel slot. So what is a video slot? What is a reel slots? Then you have tables. So all these things you have to understand. Without doing anything, you can't do any analysis. Game category code, game physical description, upright, double screen, unknown. You have video games like this. Flattened screen, round circle will be there. Some games will be straight on, you can play like this. Multiplayer games will be like circle and the screens will be not upright. It will be flat. Upright means one player only can play. So you have to understand all those things. Then zones, categories, game denomination, amount, 1 cent, locations. So without understanding, what analysis you will do here? See, gaming day, game start time SK. SK means the same date in numerical format. This is the actual date. This is the numerical format of the date.
So here play time and play minus same value.
He has immediately done a he decided and played without waiting. Yes. Yeah. You have to find whether both are same, then you have to make a decision. I think here they're same. We found out it's same. Yes. It's a duplicate. It's not a duplicate column, but values are duplicate. So no change in the data, so we deleted it. So it all depends. So you need to have a complete understanding of the data you need to do. So Medicare, healthcare data, you have to do at hospitals. Luckily, that guy, the Sai Charan, his uncle was hospitalized. He has that record, patient record with all the discharge. There he got all the list of things. Syringes, injectables, all those things the hospital gave you, the complete billing and all. So all the words he could pick up from there, and then he searched the rest of the thing on internet and he did it. Because doctors will claim detailed bill has to be given. So all those things you have to have. Without understanding, you can't work on data. Sometimes you need to take time, understand the data. So hotels, data, Another common data we see, hotels, online ticket bookings, all these things, you need to understand the business model. You need to have understanding of the way they operate. Then only you can work. And it is your job to understand. Nobody will help you. You have to use YouTube, articles. Once you have understanding, then you start working on the data.
So what is the need of slicing the data?
Huh?
What is the need of slicing the data?
Then how will you get this FD, NC, DR?
So put it here is
Where?
down there.
Okay.
It's really like a 3D and video. In
How many categories you got? 71 categories you got. Where is 3 categorization? Where is 71 categorizations? Which is better, 3 categorization or 71 categorization? So you have to do it based on the understanding. Food category, third letter changes means, that means the first 2 letters only have to change. Take. If you try to create, luckily you are 71 only. On real-time data, you might get 7,000 categories. What will you do with that data? 7,000 categories data. So you have to look at the data, understand it, and then observe. So a lot of observation has to be done. Third alphabet only changing. First 2 are common in most of the cases. So I took the first 2. Then when the value counts, it confirmed me the categorization, FD, DR, and NC. All right. So the number next is item weight we have already dealt with. Item weight we have already corrected it, so there is no problem. Combine DF dot item fat content dot value counts. The third variable is fat content. So what's the problem here? Basically, there are only 2 categories. But because of the wrong data entry, duplication is happening. Combine DF dot item fat content is equal to combine DF dot item fat content dot replace square bracket LF comma single quote low fat. These are the things we are replacing it with what? Capital L low space capital F fat. Replace it. First, you have to give what needs to be replaced. Second, the replacement. Combine DF dot item fat content is equal to combine DF dot item fat content dot replace reg with regular R capital. So in replace, first, what needs to be replaced? Second, the replacement. First, there is the replace, what needs to be replaced. Second is the replacement. Multiple things you have to give in square brackets. Multiple arguments have to given in square brackets. All the three? New one means?
If there are like select, low, fat, and there's something like available. So the idea is low fat was used to the square and creating another column.
Why do you need to create another column? You should not create another column. That will change the data structure. Column additions or deletions are very dangerous in data science. You unnecessarily can't create columns or you cannot delete them. There has to be a reason. Whatever you are trying to do, you have to do in the existing columns. New column creation will affect your data performance completely. And it will alter the data structures also. Yes, give it in the place of replacement. Huh? What is it? Same thing you can do, right? It's a variable name change. It's not this thing. We call it as category name change. Category name change you can do anytime using the replace. Dot replace can be used to change the name of a category anytime. First, you give the category name to be changed, then what is the name to be changed.
We can't add the separate column.
You can't add separate columns. So the next variable is item visibility. Combine df dot item visibility. It's a numeric column described. Nothing to be done here. Full variable, all the values are there. Mean, median, mode, everything is clear. No issues with this data. The next variable is item item type. Now, item type is a categorical data. So we have different types of items. Numeric described. First session, I told you the same thing, right?
Here, in data preprocessing, we are changing the values of the column and we are adding new column.
Hmm.
So, all that is, we get the answer with special, before we come to the.
After this, you can do. Item MRP. New row, new column. New cell. The plus sign. Insert cell above or below. It is control plus. Where is that one? Control plus A. Because I am using Mac. Check your C. Go to help. Keyboard shortcuts. Help and keyboard shortcuts in Jupyter Notebook. And then you scroll down to insert a cell above and below. Only A. Hey, only A. Only A you use. For me, it is command A or control A. No. Command shift A. I don't know. Generally, I use plus sign, but keyboard shortcut, I don't know. You check it from there only. Combined DF outlet identifier. So we have different outlets. Outlet establishment year. We will create a new variable called outlet underscore age as of 2022 based on the variable outlet underscore establishment underscore year. See, generally years and all we delete them. They are not much use, but we can extract some information. Like the establishment year is there. So I can calculate the age of the outlet, which will be a new variable based on the outlet establishment year. So combined year, square bracket, single quote, the name of new column, outlet underscore age is equal to 2022 minus combined DF dot outlet establishment year. Combined DF dot outlet age dot describe. So minimum 13 years, maximum 37 years. Age of the outlet. Now we can delete establishment year. So two columns we will delete, identifier and establishment year. Because we have extracted information from these two variables, we can delete those two variables. Okay. What year you have taken? What difference you are getting? Outlet identifier. Sorry, outlet identifier is what, no? So what is the next variable? Outlet location type. Location type. Tier 1, Tier 2, Tier 3. What is the next variable? All right. What is the last variable? The dependent variable, right? So auto-modeled sales is a mixed type, so we can't do anything right now because half of the data is numerical, half of the data, 70% of the data is numerical, the other data is categorical. Now, combine df dot info. So we have object data and numeric data. We have object data and numeric data. Combine df dot columns. Now we have to split the data into numeric and object. Numeric calls is equal to combine df double square brackets. Item weight is numerical. Item visibility is numerical. Item MRP is numerical. Outlet age is numerical. Now, item outlet sales also, I'll keep it as numerical. We will, that's actually numerical, that we'll split it later. That's categorical, na?
And what about the establishment here?
We have created new variable age, then why will we take the establishment here? Identifier and establishment here we have to drop because we have created new variables from them. Once you create a new variable from an existing variable, you dropped it. Otherwise, it will be duplication. These are the numeric calls. Object calls is equal to combine df double square bracket item fat content item type. Yes. Yes. Outlet identifier, outlet size, outlet location, outlet type, and item code.
In the corporate columns, why you take this item identifier?
We have to drop it now. We have extracted item code from it. All right. Huh? No, we have created a new variable from the existing variable. We have to drop the previous variable. You have extracted information from one variable, then what is the point of keeping that other variable? Otherwise, you keep the other variable and don't extract any information from the variable. Year itself will be not give you any advantage, right? Age of the store will give you an advantage as a variable. The age of the store will determine the outlet sales. So you have to think and get the information and delete the previous version. Okay?
Sir, item outlet sales.
Ah.
So we have some history of.
That we'll deal later. As of now, we don't need it, but basic data structure is what? Numeric, right? You have to keep it in numeric columns only. But in numeric also, it is a mixed data type. That has to be dealt later. But what is the basic data? It is numeric data. Now, why we are selecting, why we are doing this? Because we have to dummy encode object columns. We have to dummy encode object columns. We can't dummy encode numeric columns. So what is the object columns? This is the object columns, which is all text. We have to do dummy encoding or label encoding. Object calls dot head, dummy encoding or label encoding. Now, first run label encoder from sklearn dot preprocessing import label encoder. LE is equal to label encoder. Object calls underscore label encode is equal to object calls dot apply le dot fit underscore transform. Now, what is the change? Object calls dot head. Let us say 3. These are the 3 rows of object calls. Object calls underscore label encode head 3. This is the label encoded data. Got it?
Guiding is, I mean, this constant.
Then what is the doubt?
We
You have to apply the function, not transformation. Transformation. You have to transform the data. Fit underscore transform will transform the data from text to, that's what I'm showing now. Fit underscore transform will transform the data from text to numbers, 0 to n levels, alphabetical order. The function to transform the data is le dot fit underscore transform, which is applied on each cell of the data. We use the word apply when you want to apply a function on each cell of the data, iterative. We use this function. Le dot fit underscore transform is the function predefined. You can give square bracket, give the column names and do it. You can't do it on selective cells, only on selective columns. Only on selective columns you can do, not cells. Got it? This is label encoding. Object calls underscore dummy is equal to pd dot get underscore dummies object calls. Object calls underscore dummy dot head 3. Now item fat content was encoded 0 and 1. Slim is 1, regular is 0. Here you see regular 1 column, slim and 1 column, 0, 1 refers yes and no. Binary column. So see here, for each item type, it created 1 column. Baking goods, breads, breakfast, canned. So it created 42 columns. For each category, it will create a column and uses binary encoding, 0 and 1. 0 being no, 1 being yes. Print object calls dot shape. Print object calls underscore label encode dot shape. Print object calls underscore dummy dot shape. So label encode did the same thing, but in the same column, but dummies created new columns. The data size have drastically expanded. హలో ఎక్కడున్నావమ్మా रिसेप्शन में दे दो रिसेप्शन में दे दो Okay, so we'll stop here and continue the next session. So we have done some basic pre-processing, which we have understood and cleaned the data and all. So in the next session, we will look at the other steps that are involved in processing. Yeah.